In this video, we're going to talk about finding the volume of pyramids and cones. So a pyramid is a solid with a base that is a polygon with lateral faces, which are triangles that have a common vertex. So a pyramid is a base that has a shape that has three or more sides. Its lateral faces, which are the faces on the outside, are going to be triangles, and they're all going to meet at a point at the top, which is what we call vertex. In right pyramids, the faces are isosceles triangles. So that's just kind of like a little bit of extra information. The altitude or the height of the pyramid is going to be the perpendicular distance from the vertex to the base. And so in this particular pyramid here, this would be our height or our altitude. The shape at the bottom here would be our base. P at the top would be our vertex. A regular pyramid has a regular polygon for a base, and the altitude, or the height, is going to meet the base at its center. So a regular polygon has sides that are all congruent and angles which are all congruent. Some examples include a square or an equilateral triangle. Okay, another piece that we have is the slant height. So the slant height of a regular pyramid is going to be the altitude, or basically the length, of any of the lateral sides. And so in our picture, our altitude would be S. So PS would be our altitude, or slant height, excuse me. So PS would be our slant height. Like prisms, pyramids are named by the shape of their bases. For example, a pyramid that has a hexagon as its base would be called a hexagonal pyramid. Okay, we're also going to talk about cones. So this shape is a cone. So a cone has a circular base, and it has a vertex that is not the same, or not in the same plane as its base. So what that means is we have a circular base, so a base that is a circle, and we have a vertex that is away from that base. So the altitude or the height of a cone is going to be the perpendicular distance between the vertex and the base. So this circle would be our base, A is going to be our vertex, and AC would be our altitude or our height. In a right cone, the altitude or the height is going to meet the base at its center. So this would be considered a right cone because our altitude comes straight down and meets at a right angle. The slant height is going to be the perpendicular distance between the vertex and a point that's on the base. So that means that this side would be a slant height, or this side. Alright, so the volume formula for a pyramid and for a cone is going to be very similar. And so the volume formula for a pyramid is going to be 1/3 big BH. And the volume formula for a cone is going to be 1/3 big BH, where big B is going to be the area of the base. So in a pyramid, our bases are going to change depending on what the shape is of the flat part in our pyramid. In a cone, our base is going to stay the same. And so in a cone, our base is going to be a circle. Our shape of our base is going to stay the same. Let me say that. So in a cone, our base is going to be a circle. And remember that the area of a circle is going to be pi r squared. And so for a cone, my area formula, or my volume formula, is going to be 1/3 pi r squared times h. And so your h is going to represent your height of the solid, or your altitude, and the r that shows up in our cone formula is going to be the radius. So in number 21, it says use 3.14 for pi and round to the nearest hundredth, and we are looking for the volume of the solid. Okay, so our solid is a cone, which means that we're doing 1/3 big BH, but big B is going to have to be equal to pi r squared, and h is going to be equal to our height. Okay, so our big B, we're going to plug in pi times our radius. Now remember that our diameter, what we have here is our diameter, and I know that because this measurement is in the center of my circle. So if they write it in the center, that means it's a diameter. If they write it on either the left or the right, that means that it must be a radius. Also notice that the dotted lines go all the way across, and so if we had a radius, it would probably only go from the center to the outside. Okay, so if 13.4 is our entire diameter, then by dividing 13.4 by 2, that would give me what the radius is. So for this problem, our radius would be equal to 6.1, just kidding, 6.7. So it would be 6.7 for our radius, which means I'm going to plug in 6.7 squared in for our base. Let me move this. Let's do this over here. So we're going to say r is equal to 6.7. Okay, so once I do that, then let's plug in for our height, what our height is equal to, and that in this case would be 10.2. So my whole volume formula would be equal to 1/3 pi times 6.7 squared times the height, which is 10.2. So you would go to your calculator and you would do alpha y equals, to get your fraction, do 1/3. They ask you to use 3.14 as your pi, so we're going to replace pi with 3.14 in my formula here. Then I'm going to do 6.7, close my parentheses, and square it. And then I'm going to multiply it by 10.2. And this is all coming from this last line right here. So then once I hit enter, that gives me 479.24564, but it asked me to round to the nearest hundredth. And so that would be the second place after the decimal. So because the third place is a 5, I'm going to bump up the 4 to a 5 as well. So it'd be 479.25. All right, number 22 says round to the nearest whole. And so the shape that I have is pyramid, so I need to use my volume formula for a pyramid, which is 1/3 times big BH. So big B is going to be the area of my base. And so my base is going to have to be a rectangle. And remember, the rectangle area of a rectangle would be length times width. And so that would be 6 times 7. So in my formula, I would say volume equals 1/3 of 6 times 7, which is 42, times the height, which is 9. So on my calculator, alpha y equals, to get my fraction, 1/3 times 42 times 9. So you get your answer is 126. All right, for number 23, it's a little bit more difficult. And so it asks us to leave our answer in terms of pi. So for our shape, we notice that it's a cone, which means that we're going to use the volume equals 1/3 big BH. And so we need to remember that big B is going to be equal to pi r squared. And so we need to know what our r is. So our r is going to be 35. So that's going to be pi times 35 squared. Okay, our h is going to be our height. Now remember, our height is going to be our altitude, which is the distance from the center point to the vertex. And so in order to be able to do that, I have to think about what information the picture does give me. So the picture gives me my slant height. And I know it's my slant height because it's the from the outside, from point on the outside of the base to the vertex. And so anything that's on the outside of my cone is going to be our slant height. So I've got a slant height, I've got the radius of my cone. Or if I'm thinking about this, remember my height's always going to come down and meet at a right angle. So what I really have is I've really got a right triangle. So I can go over here to the side and say, okay, if I have a right triangle where my base is 35, my hypotenuse is 37, using a squared plus b squared plus or equals c squared, which is my Pythagorean theorem, I should be able to figure out what this value is right here. So let's let x be a. So I got x squared plus 35 squared equals 37 squared. $35 squared is 1225. And 37 squared is 1369. So, let's say x squared plus 1225 equals 1369. Trying to get x squared by itself. So x squared would be equal to 1369 minus 1225. So it'd be 144. I'd square root both sides and get that x is equal to 12. X being what our height is. So we'll let this be x, and so now we know it's 12. So our height would be 12. Then I plug back in here. So I'm going to say volume equals 1/3 pi 35 squared times 12. So the question tells me to leave it in terms of pi, which means I just need to plug in the numbers that I have. So I'm going to do alpha y equals, to get my fraction, I'm going to do 1/3. I'm going to multiply it by 35 squared, and then multiply it by 12. So when you do that, that gives you 4,900. And so I didn't put that pi in there, so it'd be 4,900 pi. Okay, you try number 24. So you're finding the volume of a regular pyramid and if necessary, you're going to round your answer to the nearest tenth. So to find the volume of a regular pyramid, you're going to use the volume formula for a pyramid, which is 1/3 big B H, where big B is the area of the base, and in this case the base would be a rectangle, and so my area would be length times width, which would be 14 times 15. Times 15 is going to give me 210. And my height is going to be my height from the vertex straight down, which is 24. So when you plug into that formula, it'd be volume equals 1/3 210 times 24. $16.80. On number 25, it asks us to find the radius of a cone whose volume is 45 pi feet cubed and whose height is 15. So this one doesn't give us a picture, so we should try to draw a picture. So it tells us a cone. So that's not a cone. Gives us a cone, tells us it's a right cone. It tells us that the height is 15, so this is 15, but we don't know what the radius is, so we're going to let radius be r. Okay, so we know that it's a cone, we know we found the volume, so its volume equals 1/3 big B H, but big B, because it's a cone, is pi r squared. So that formula then is going to be volume equals 1/3 pi r squared times h. So I just replaced the b here with pi r squared. Okay, so then I know that the volume is 45. Got my 1/3 of my pi. Still don't know what r squared is going to be, but I do know that h is 15. So if I want to get r squared by itself, I'm going to divide by all the stuff that's not r squared on that side. So 1/3 pi times 15. Okay, so my calculator will do all that for me. So I'm going to go to my calculator, go to y equals, get my fraction, do my fraction. On the top, I would have 45. And then on the bottom, I'm going to have another fraction because I got that 1/3. So I'm going to do 1/3. Got to get out from underneath that fraction. Remember, I want it to look just like this. I'm going to multiply it by pi. So to multiply it by pi, I'm going to do second caret to get my pi. And then my height was 15. So I'm going to do my parentheses and do 15. So whenever you do that, you're going to get 2.86. So we'll just do 2.86. So that'll cancel. That'll cancel. That's going to be r squared equals 2.86. But I got to get r by itself. So I'm going to square root both sides. So go over here. I'm going to do second x squared. Let's go ahead and copy that down here by just going to the up arrow, hitting enter, and see how it pops up in there. That keeps you from having to type it all in again. So then you hit enter, and you're going to get let's do 1.69. So r equals 1.69. Number 26 says the Great Pyramid of Giza has a volume of about 49,400. Oh, just kidding. 49,439,277 meters cubed. The length of the edge of its square-shaped base is 1,924 meters. Approximate the height of the pyramid to the nearest meter. Okay, so we know it's a pyramid. We know that our base is going to be a square. So we're going to pretend like this is a square. So this is our pyramid. So the length of the edge of its square base shape. So one edge is 19,000 or 1,924. And we know that the volume is going to be 49,439,277. So volume formula is 1/3 big B H, but our big B, because it is a square, is going to just be the two sides multiplied together. So it would be like length times width, but that would be 1,924. Just kidding. Whoa, it's super late, y'all. Sorry. So I'm going to multiply those two numbers together. Or I can just square them. And whenever I do that, it gives me 3,701,776. It's a big number. Okay, so I know that my volume is 49,439,277 equal to 1/3 times this big number here times the height. Okay, so we can go ahead and simplify that a little bit. So we're going to keep this side. We can go ahead and do 1/3 of this number. So let me go ahead and copy this. And I'm going to multiply that by 1/3. And then I'm going to divide both sides by this big number. This problem is really awful. I hope that you don't have any like this. So we can do all that in the calculator. So we're going to say 4,943,9,277 divided by 1,233,925.33, and then hit enter. So when we do that, it gives us about 40.07. But it does say approximate the height to the nearest meter. So we'll say 40. So 40 equals H. So all of that to get 40. All right, last one. The 14-inch tall birdhouse below is made up of a cone placed on top of a cylinder. Find the amount of birdseed that will fill the birdhouse to the nearest hole. Okay, so I've got two pieces. It doesn't tell me much about my cone, but I can figure it out because, for one, the radius of my cone is going to be half of the diameter. So if the diameter is 10, that means that the radius is going to be 5. Okay, now it also tells us that the whole thing from top to bottom is going to be 14. But my cylinder at the bottom was 8. So if my cylinder at the bottom is 8, then I would say 14 minus 8 to get whatever the height is here. So if it's 14 minus 8, that'd be 6. And so remember, your height is always going to meet up with your radius at a right angle. So our entire birdhouse, the volume of the entire birdhouse, is going to be equal to the volume of the cone plus the volume of the cylinder. So let's start with the volume of the cone. Okay, the volume of the cone is going to be 1/3 big BH, where big B is going to be equal to pi r squared, and our r is going to be equal to 5. So the volume of the cone is going to be equal to 1/3 pi 5 squared. Our h is going to be equal to the height of the cone, which is 6, times 6. So I can plug that in the calculator. And so that's going to give you 157.08. It does say round to the nearest whole, so let's just leave it at 157. Okay, so now I got to do the volume of the cylinder. So volume of a cylinder is going to just be big BH, where our big B is going to be pi r squared. And so our R, we said, would be 5. Our H for our cylinder is going to be 8. And so when we plug into the volume of the cylinder formula, it's going to be pi times 5 squared times 8. So on my calculator, pi times 5 squared times 8 will give me 628. And so then I just have to add those two numbers together. So 157 plus 628. 785. So my volume of my entire birdhouse would be 785 inches cubed.